Please find a quiet place to sit or lie and to listen to this audio. Once seated, close your eyes. Focus your attention on your breath. When you're ready, inhale slowly. Let the air fill your lungs. And then, exhale slowly. Let the air escape from your lungs. Inhale again. And then exhale again. Notice how your stomach rises as you inhale and then falls as you exhale. Rises as you inhale and falls as you exhale. If your mind wanders, don't be concerned. Just gradually shift your attention back to my voice. Part 2. Now orient your attention to your thoughts. In particular, you will notice that many thoughts, images and memories might pervade your awareness. Perhaps identify one thought that is not very pleasant. Examples include, this exercise is a waste of time, or I'm not clever, or my memory is poor, I'm not sure I'll pass, or I'm bored. Try to repeat this thought to yourself, but very slowly and deeply, as if you have somehow reduced the speed of this audio. You might repeat to yourself, I am bored, or I am not clever, very slowly and deeply. Or you could repeat this phrase in another voice, perhaps with a different accent. You might repeat to yourself, I am bored, or I am not clever, with a child's tone. These exercises help you feel you can watch and change your thoughts. You do not feel as trapped by your worries and concerns. Sometimes, a part of the body might need to be removed, such as a tooth or finger. Yet after this body part is removed, people sometimes experience unusual sensation. They still feel pain, tingling, or some other sensation in this body part. A tooth, although extracted several years ago, might continue to hurt. A finger, although lost, might tickle. Even an entire arm or leg, once removed, might continue to elicit pain, called a phantom limb. So how can a tooth, finger, arm or leg that is removed continue to evoke pain, tingling, or other sensations? Part 3. To understand the source of these sensations, you need to visualize the system that enables you to feel touch, pressure, pain, and other sensations, the somatosensory system. Specifically, imagine you can see under your skin. Under the skin are many layers of cells. Perhaps you can imagine these layers of cells resembling the stuffing of mattresses. Embedded within these layers are a diversity of receptors. Now, some receptors look something like discs or frisbees. Other receptors look something like onions or mushrooms or other shapes. Whenever the skin is displaced, squashed or affected in some way, these receptors send an action potential, like a spark of energy, down a long hose called an axon. Perhaps you can imagine this spark of energy travel along this hose or axon from the skin, such as on the wrist or finger, towards the spinal cord. This action potential, after reaching the spinal cord, then evokes another action potential in a neuron that travels from this location to the thalamus, a region embedded within the cortex of the brain, a few centimetres behind the eyes. From some angles, the thalamus resembles a very thick caterpillar. Perhaps you can imagine this burst of energy travel from midway up the spinal cord towards this thick caterpillar, several centimetres behind the eyes. This action potential, after reaching the thalamus, then invokes another action potential in a neuron that travels from this location to the somatosensory cortex at the top of your head or brain on both the left and right sides. Part 4. This somatosensory cortex looks like a thick but small cloth. Each location on this cortex corresponds roughly to one location on your body. To illustrate, imagine that someone touches your left thumb. You can visualize how this light touch displaces or squashes a receptor in the skin of your thumb, a receptor that resembles a disc or frisbee. Then notice how the axon that emanates from this receptor transmits something like a spark of energy from this location to the spinal cord, and then to the thalamus embedded inside the cortex, and finally to one cluster of neurons in the somatosensory cortex on the right side of your brain at the top of your head. Hence, this location in the somatosensory cortex essentially represents your left thumb. For a few seconds, imagine this region at the top of your brain. You could even imagine a tiny thumb in this region, although of course the region does not actually resemble a tiny thumb. Now, imagine that someone touches your left ring finger instead. Again, visualize how this light touch displaces or squashes a receptor in the skin of your ring finger, a receptor that resembles a disc or frisbee. Then notice how the axon that emanates from this receptor transmits something like a spark of energy from this location to the spinal cord, and then to the thalamus, and finally to another cluster of neurons in the somatosensory cortex on the right side of your brain. And these neurons that are activated when the ring finger is touched, are a very short distance away from the neurons that are activated when the thumb is touched. For a few seconds, imagine this region at the top of your brain. You could even imagine a tiny ring finger in this region. So each location in this region of the brain corresponds to one location on the body. Part 5. But now suppose your ring finger is removed. Consequently, the receptors in this ring finger are also removed. No axons can send sparks of energy from the ring finger to the corresponding location in the somatosensory cortex at the top of your head, the location in which you would imagine that tiny ring finger. So consequently, these axons begin to generate. So for example, the axons that travel from the thalamus to the location in which you would imagine the tiny ring finger at the top of your head gradually vanish. You might therefore assume that you will never feel pain, tingling, or any other sensation in your ring finger. However, over time, an interesting change unfolds. Initially, no axons are connected to the cells at the location in which you would imagine the tiny ring finger. This location is therefore vacant. You might even visualize a small vacant sign at this location in the somatosensory cortex at the top of your head. Over time, however, other axons from various regions of the brain respond to this vacancy. Axons begin to grow and advance towards this vacant location. One set of axons from a particular region is likely to prevail. These axons might have grown from many regions of the brain, such as regions that process sights, sounds, smells, or tastes. To illustrate, suppose the axons that analyse a particular scent, such as the aroma of coffee, advance towards this vacancy in the location in which you would imagine the tiny ring finger. Now imagine the aroma of coffee drifts into the nostrils of this person. Consequently, the neurons that correspond to this scent will be activated, and these neurons will send action potentials like sparks of energy to the location in which you imagine the tiny ring finger. So therefore, this region, the somatosensory cortex, at the top of your head, will be activated by the aroma of coffee. Previously, when this region was activated, you felt a tingle in your ring finger. So now when this region is activated, you will still feel a tingle in your ring finger. The aroma of coffee will thus elicit a tingle in your ring finger. You will not, however, realise the scent of coffee was the source of this tingle, because the association between coffee and touch seemed so unlikely to you. Instead, you will feel a tingle as if someone had touched your ring finger, a ring finger that had previously been removed.